Hi there, ladies and gents. We are going to do some solving equations. We're towards the end of our solving equations time. And we're going to chuck in what I think is the bit that's most confusing for most people, which is some fractions. But first of all, I want you to have a look at these three fractions that don't have any solving side to them. There's no algebra in there. I just want you to remind yourself of how to add fractions. And so pause the video, add the fractions, and then unpause when you're done. Go. Okay, so we have unpaused. Now remember, when we're adding fractions, we need to have a denominator, that's the bottom number to you and me, we need to have that the same. And so we're looking for a number that they can both go into, and actually a couple of these, look, the 5 will actually go into 10, which means I only need to change one of my fractions. The 1 over 10 can stay. What I want to do is change my second fraction, so it's also over 10. Now if I'm going to get 5 to become 10, I've got to think about what I'm going to times it by, and I'm going to times it by 2, and if I times the bottom by 2, I must times the top by 2, because I don't actually want to change my fraction. I just want to get an equivalent fraction that's still the same proportion. That's the thing. 3/5 of a pizza is the same amount of pizza as 6/10 of pizza. Pizza. Anyway, so we're going to now add that. We got 1/10, we got 6/10. We add those together and we got a total of 7/10, okay? So that's what we're looking at. Now this next one, let's see, does one of the numbers go into the other? Yes, it does. The 7 will go into the 14. So I only need to change one fraction. So that the first fraction is now over 14 instead of 7. Now what have I done to 7 to get to 14? Well, actually I've times it by 2 again. It's not always times it by 2. That's just a coincidence with the first question. So I'm going to times the top and the bottom by 2. So 2 times 2 is 4. And now they've got the same denominator, I can add them easily. 4/14 and 3/14 makes 7/14. Ooh, and I can simplify that a little bit further as well, because if I divide the top and the bottom by 7, because they both divide by 7, I will get a half. So 1 over 2 as well. And this last one, now there is no number, well, so one of the numbers will not go into the other. 4 will not go into 5, 5 will not go into 4. Not very easily anyway. So we'd use a different strategy here. I'm going to look for the lowest common multiple that they both go to, and actually in this case, it's the number that you get when you times the two bottom numbers together. 4 times 5 is 20. Okay, so I'm going to get two fractions over 20, and that's a method that always works. Now, the 4 was times by 5, so I'm also going to times the 1 by 5 to get 5. And the 5 was times by 4, so I'm going to times the 2 by 4. This is this sort of cross-multiplying thing going on. 4 times 2 is 8. And these two fractions are the same as these first two, just with different numbers. It's the same proportion. Now, 5/20 and 8/20 is 13/20. Okay, so it's a little bit of a reminder about how to add fractions. We shall come on to that later. But for now, let's start off with something a little bit easier. Okay, here are 3 different fractions or different equations with some kind of fraction element. And this is algebra as well, so these are ones we could solve. And the first thing I want you to do is actually have a look at these 3 and see what's fundamentally different. And these are the 3 main types, I think, of fraction that we're going to solve. So have a look, pause the video, have a little think about what's different about the 3, and then unpause it when you're done. We have unpaused. Okay, right, now this first fraction, notice that, okay, all equals 5, it says drawn on the screen, but this side is all over a denominator. The whole thing is over a denominator. Okay, so that's what's different about this one. This one, we don't have that. It's not the whole thing that's over the 3, it's only the a, so only part of it is over a denominator, and that would need a different strategy to the first one. Okay, now this last one, they're both over a denominator, but they're over different denominators. So this is a case where we would have to add 2 separate fractions together. Okay, let's have a little look at the first 2 then. So we're going to work on the first 2, and then we'll come to this third type later on. So the main difference between these first 2, when we look at these, is the fact that one of them is over the whole thing is over a denominator, and this one is only partially over a denominator. Okay, now the first strategy we're going to use, if the whole thing is over a denominator, this is nice and easy to deal with. Now, what we really want is an equation that doesn't have a fraction at all. It's just a straight line, like we've done before, because that makes it a lot easier. Now, if it's all over a denominator, that's nice and easy. We can get rid of this divide by 3, because remember, this line means divide by 3. Now, everything here is divided by 3. So instead, I'm going to times it by 3. And that timesing by 3 cancels out the divide by 3. Yeah? And once that divide by 3 is cancelled out by the times by 3, all I'm left with, the fraction disappears, and I'm just left with the top part. But remember, what you do to one side of an equation, or one side of an equal sign, you must do to the other. So I must times this side by 3 as well, to keep the whole thing equal, keep it balanced. If I've made this side 3 times bigger, this side must be 3 times bigger. And 3 5s are 15. Okay, so that's our strategy. That's our main strategy. If everything is over a single denominator, we just times by that number to remove that denominator, remove that fraction part, but do it to both sides. All right. Okay, now we've got a straightforward one-step equation to solve. I'm going to get rid of the plus 4 by taking away 4. I'm going to do it to both sides. So a equals 11. So the only thing that's different with this than something you've done before is that we times everything by 3 first of all to get rid of that fraction. Now I can't do that to this one over here, or rather I can, but it would give me a slightly weird answer. I'm actually going to change this side, this left-hand side, so that the only thing left is everything that's over the denominator. This stuff that's kind of on its own, this number that's loose, is nice and easy to remove. We did that before, didn't we? We always dealt with the number that's near the letter last. We'll deal with this number first. Now, how do I get rid of a plus 4? I subtract 4. Because 4 take away 4 leaves nothing. It will just leave that fraction bit, won't it? But what I do to one side, I must do to the other. So I'm going to take 4 away from this side as well. Now, 5 take away 4 is 1. Now look at this. We have done these ones before, actually, haven't we? Where something is divided by something. If I want to get rid of that, we said that we times by it, don't we? And we do it to both sides. This side is all over a denominator, so to cancel it out, I times by that denominator. And that will just leave a on its own. But I must times this side by 3 as well. So it's 3. So if not all of one side is over a denominator, deal with the loose number first, the number that's on its own, because that's really easy to deal with, and then you can deal with the fraction. Okay, right, here's 2 examples for you to do. I want you to pause the video, do the examples, and then see how you get on. Okay, so pause now. We have unpaused, or as they say in France, we have unpaused. Okay, let's have a look at this. So what have we got here? Oh, right, this one. This is the type. This is the second type, isn't it? Where not everything is over a denominator. So I need to remove a number first. I'm going to remove this minus 8, and I'm going to do it by adding 8 to both sides of my equation. Okay, so 8 take away 8 leaves nothing. So this fraction is left all on its own. All by itself. Anyway, this side, we're going to add 8, so 2 plus 8 is 10. Okay, and then we know that all of this side is over a denominator. That's easy to get rid of. We just do the opposite. It's a one-step equation, isn't it? The opposite of divide by 5 is times by 5. Those two things will cancel out to leave x on its own. So I just times by 5 to get rid of the divide by 5. But I must do it to both sides to keep the whole thing balanced. Keep the whole thing equal. If I don't do it if I only do this side, make this side 5 times bigger, well, this side won't be equal, will it? I need to make both sides 5 times bigger. Oh, this is also type 2, isn't it? This is a type 2 equation. That's just made me chuckle, don't know why. This side, right, okay, what have we got? We've got not everything is over the denominator, so we'll deal with this loose number first. And let's just take away 1. 1 take away 1 leaves nothing. Just leaves y on its own, y over 4, sorry, on its own. But I've got to do it to both sides of my equation. 7 take away 1 is 6. Oh, but how do I get rid of this fraction here? Y divided by 4. I don't want it divided by 4. I want it just as y, don't I? And I do the opposite. I times by 4 because divide by 4 times by 4 cancels out to leave y on its own. But I must do the same to this side as well. 6 times 4 is 24. Okay, hope you got that right. If you did, you get a tick and a tick. If you didn't, then, maybe watch it again. Okay, 4 more for you to have a go at then. So I want you to pause the video. Now you're cracking. Let's go on. We're cooking with gas, as they say. Get on, pause the video, and off you go. We have turned off the gas and unpaused. All right, okay, I'm going to go a little bit quicker this time. This is obviously that second type, isn't it? I'm going to take away 4 from both sides, because that will leave a over 3 equals 5. And then I'm going to times by 3 to get rid of the fraction, to leave a on its own. But I must do it to both sides. So that's a equals 15. Is that that looks awfully like the first example I did. Anyway, number 2, right, okay, oh, this is the first type, isn't it? Everything is over that denominator, so my first step is going to be to times by 5, because that will cancel out that denominator and just leave t plus 3 on its own. But I must do it to both sides as well, so this will be 1 times 5 is 5. And then I can remove the 3 by taking it away. Take it away from both sides. T equals 5 take away 3, which is 2. Oh, I'm really proud of that 2. My writing's awful. That's like a proper primary teacher writing a 2. That's amazing. Okay, what have we got over here? No, not everything is over the denominator, just the 5. So we need to remove this loose number first, this easy to remove number. So opposite of minus 3 is plus 3. Now, I know there's a couple of people now going, oh no, I took away 3. Now, you've got to do the opposite. You've got to add it to turn it into nothing, because 3 take away 3 is nothing. That will leave 2x over 5 on its own, leave that fraction on its own. But I must add 3 to both sides to keep the whole thing equal. What do you do to one side of the equal sign, you must do to the other. 2 plus 3 is 5. Oh, I've still got a couple of steps here, haven't I? Now, everything, though, is over this fraction line, over this denominator. So I'm going to remove that denominator by timesing it by 5. That will cancel out that division, just leaving 2x on its own. But I must do it to both sides. So that's 5 times 5 is 25. And then I'm running out of space on screen. But remember, if we've got, I don't want 2x, I just want x. So we divide by that number, touching the letter. So we're going to halve it. I don't want 2x, I just want one of them. And that should be 12.5. Lastly, okay, this is that second type, or that first type again, isn't it? Everything is over that denominator, so that's the first thing I'm going to deal with. If everything's over it, we deal with that first. And I'm going to times by that number because it will cancel out the division, leaving y minus 1 on its own. But what I do to one side of the equal sign, I must do to the other. 2 times 3 is 6. And then lastly, to get y on its own, I'm going to add 1, because 1 minus 1 leaves nothing, so y is left on its own. But I must do it to both sides, so y equals 7. Well done if you got all 4 of those. Oh, 2 more examples. Yeah, we're gonna really plow through some of these now, aren't we? Okay, right. What do you think I've got to do here? What side type is this? Yes, you're right. Everything is over the denominator, so that's the first thing to get rid of. Instead of dividing by 5, I'm going to times by 5, and that remove my denominator. So 2x plus 5. But I must do it to the other side as well, so that will be 9 times 5, which is 45. Then we've got a 2-step equation to solve. Deal with the number touching the letter last. We should be really good at those by now. So I'm going to deal with the plus 5 first by taking away 5. 5 take away 5 is nothing, so that leaves 2x on its own. 45 take away 5 is 40. Okay, and now I don't want 2x. I don't want to know what the value of 2 of them is. I just want to know what the value of one of them is. And I'm just going to take a slight aside here, because I'm sat right next to the back door whilst I'm writing this. Remember, divide by that number. And it's freezing, because do you know what? Someone's come in and left the back door open. And they're now running over to close it. Right, 2x equals 40. I don't want 2x, I just want the 1, so I divide by the number touching x. Yeah. That was the door you just heard shut. 40 divided by 2 is 20, so x has the value of 20. Sorry about the distraction there. Right, this one. What am I going to deal with first? Am I going to times by 4? No, because not everything is over that denominator, is it? So the first thing to do is get rid of the minus 3 by doing the opposite. Add 3. I bet you're getting really good at these by now. So plus 3 and minus 3 cancels out. So we're left with 3x over 4 on its own. But this side we need to add 3 as well. 6 plus 3 is 9. It's all about keeping it balanced, isn't it? All the time. Whatever we do to one side, do to the other, because it keeps the whole thing equal. Now I don't want this over 4. I don't want the fraction. How do I get rid of divide by 4? Yeah, you're right. I times by 4. So we times by 4 and that cancels it out. I do it to both sides. 9 times by 4 is 36. But I don't want to know the value of 3 Coke cans or 3x. I want to know 1 Coke can or 1x. So I divide the price by 3, don't I? Which tells me that one of those x's is worth 12. Yeah? So, you know, we're doing the main thing here is to decide. Is everything over the denominator, in which case times first? Or is only one bit, in which case deal with the separate number first? 4 questions for you to do again, so off you go. It's your turn. Pause the video and off you go. Okay, we've unpaused. Right, I'm going to rattle through these quickly because you're getting good at these now. It's all over 2, so I'm going to times by 2. Okay, and that will cancel out that. And we're left with 3x plus 3. But I need to times this side by 2 as well, so that both sides have been doubled. So it's 18. Two-step equation, deal with the number touching x last. So I'm going to take away 3 from both sides, which will leave 3x equals 15. And then lastly, I don't want 3x, I only want 1. So I divide by that number touching x. So x is 5. Number 2, everything is over this 4, so I can safely times by 4 to cancel it out, to make it disappear. So 2y minus 1 equals, well, this side also needs to be times by 4, and so it's 12. Then what am I going to do here? You're right, I'm going to add 1. I'm going to add 1 to both sides. So minus 1 and plus 1 cancels out to leave 2y. And 12 plus 1 is 13. Now I don't want 2y, I only want one of them, so you divide by the number touching x. You divide by the number touching x, which is 6.5. And then what have we got over here? We've got 4x over 5 plus 2 equals 10. Okay, only part of it is over this fraction, so I need to deal with the plus 2 first. I can't deal with this yet. Let's just get rid of the easy thing to get rid of first. Take 2 away from both sides. So we're left with the fraction on its own, this side. And 10, take away 2, is 8. Now everything is over that fraction line, that denominator. I can times by the 5 to remove it from this side, but this side also becomes 5 times bigger, which is 40. Now if 4x is a 40, we only want one of them, so we divide by the 4, which is 10. And then last one, okay, this looks like everything's over the denominator, doesn't it? There's that fraction line. But look, this is separate. I chucked this one in there just to see if you were listening. Right, look at this. Not everything is over the denominator, so the first thing to do is to add 4 to both sides to get rid of that minus 4. That means this side still has a fraction, and it's still got quite a lot going on. But now everything is over that denominator. So I can times by 3 to leave 8y plus 2, because that has cancelled out my fraction there. And that equals 24. I'm going to take away 2, or I'm desperately running out of space here, which is 22. Which is 8y. And then Someone has definitely made a mistake here in this question, haven't they? Because how do I get from 8y down to 1y? You are right, he says, right at the bottom of the screen. I divide by 8. And how many 8s in there? I think that's going to be 2.75. It's 2 3/4. Tricky division there, but hopefully you've got the rest of that particular sum right. So 2.75 there. He says, you know, I'm starting to doubt myself. It's late in the evening and I'm really starting to think I'm going mad. No, of course it is. Of course I'm right. Why wouldn't I be right? Okay, let's have a look then. I think that we're going to leave it there for today because that's quite a lot of thinking you've had to do. Tomorrow we'll do a little bit more on this, on the other type of fractions, and then we'll add a My Maths task onto the end of it as well. Okay, so well done for all that work. And if you want any extra questions, you can always email me and I'll chuck you some questions. But I think you've probably worked quite hard enough today. All right, well done.